Hi, Assalamualaikum warahmatullahi wabarakatuh and a very good morning. My name is Muhammad Aiman Bin Halim and my matrix number is DN200055. So today I'm going to present about my PSM2 under a topics of Footstep Piezoelectric Sensor Power Generation project. Alright, so for the abstract of this project, first we are looking at the importance of this research. So the demands for power in the modern world is rapidly growing and it's accelerating, and there are endless numbers of ways that we can produce a renewable source of energy, and one of those ways is by generate electricity through footstep. And next we can see from the abstract is the problems that this project attempts to solve. So as the demand for electricity continues to grow, it becomes important for us to explore and implement alternative for us to gain the energy. And in this project, the piezoelectric sensor are placed below the platform, which is pad that I create, and in order to generate a voltage when a footstep is detected, and the piezoelectric sensor have the capacity to generate a higher quantity of usable energy if the number of steps taken or being stepped on the pad surface are high, and each of the step on the piezo sensor pad can produce approximately around 0.020 volt to 0.050 volt. So next we are going to look at the introduction of this project. So to achieve the environmental sustainability, it is very important, essential for us to implement this clean energy solution, and one of the effective method that can be used to generate electricity is from footstep energy, where the kinetic energy generate during walking as a renewable energy source. And by implementing this footstep power generator with the piezoelectric sensor being attached, the waste energy from walking can be converted into a usable electricity. And this project is particularly better to place in the public areas such as bus stop, mall, university campus, where there is a high people walking at that area, and installing this device can generate voltage which is a footstep that being produced. Alright, so for the objective of this project is first to design a renewable circuit by using piezoelectric sensor. Number 2 is to develop a prototype that is capable of producing energy from human footstep through utilization of piezoelectric sensor. And lastly is to analyze the data occurred from piezoelectric sensor under applied pressure. So next, for the methodology, in this slide I attach my 3D layout and my full dimension of this project. So basically this 3D layout is going to be my guide, right, for me to develop this product. And as panels can see at the 3D layout, there is the main parts, which is there is a piezo sensor pad, alright, and another main part is the PVC box, where I put all the components that I have connected in the box, and to make the project functionally well. Okay, so this is my schematic diagram that I attached in this slide, where as we can see here, there is a piezo sensor, alright, that I attach, make it as a one pad. Okay, and next at here we can see there is a full rectifier bridge, where it will change the AC voltage to the DC. and next we can see there is a capacitor, okay, and there is also a buzzer, alright, LCD display for display the voltage value. And next the main part is the Arduino Nano, okay, and next we have a voltage sensor, and we also have a battery, and we also have a motor. So for the schematic diagram of this project, Footstep Piezoelectric Sensor Power Generation Project, as I showed in the previous slide, I construct this schematic using a freezing software, and it showed the whole connection of the component in the connection, and we use the piezoelectric sensor to change pressure force into electric charge using a piezoelectric effects. And the connection also involve Arduino Nano, voltage sensor, rectifier, capacitor, and after the piezoelectric sensor pad is connected to the other component, it will generate electric, and the electric that generate will be direct to a bridge rectifier, which is used to change the AC volt to DC volt, and it will be stored in the capacitor, and the capacitor will be storing and discharge the electric charge, and the cumulative electric readings in voltage are displayed on the LCD. And when the switch 1 is being pressed, it will release the voltage, and when the switch 2 is pushed, the battery voltage, if it's lower than the capacitor, the capacitor will discharge and charge the battery, and as the result, the motor can be activated. So as a result, this is my data collected when I apply 10 step to 100 step. So as we can see here, if we apply 10 step, we can generate around 2.22 volt, and charging also the same, 0.22, 20 step 0.88, 30 step 1.00 volt, 40 step 1.46, 50 step 2.25, 60 step 2.59, 70 2.94, 80 3.35, 90 step 3.71. But at this point, the charging voltage will only have 3.7, and if 100 step, it will show 4.1, but at the charging storage also it state only 3.7, and at 120 step, the cumulative reading of electric voltage that being collected is 4.6, but at the charging voltage still 3.7. Alright, so as we can see from the data collected from the previous slide, we can make observation, whereas the stepping frequency increase, it will also increase the generate voltage, and the higher the frequency, causing the more frequent mechanical stress on the sensor pad, and it will result a greater amount of electric charge. And the charging storage, it will somehow at a certain stage, it will remain the same, which is 3.7, where it is the battery maximum. And if there is any increasing in the generated voltage, the generate voltage cannot be stored anymore in the battery, because the battery cannot hold the additional charge beyond its capacity, and the voltage generated by the piezo sensor on the pad still can increase higher if we apply more and more pressure, but at one point the battery only can charge 3.7 volt, because it already reached the maximum value of the battery. and this is the result of my project, which I show in the graph. So as we can see, the graph is increasing as the number of step increase. The value of voltage generated also will increase, but at the certain point, around 3.7 voltage, the charging storage will remain the same, because it already reached the maximum of the charging in the battery. So as a conclusion, my project, the Footstep Piezoelectric Sensor Power Generation projects, successfully convert the footstep pressure into electrical energy using a piezoelectric sensor. Although the voltage gain quite small, but the sustainable and renewable energy generation method demonstrate the effectiveness of the piezoelectric effects and the integration of components like Arduino Nano, voltage sensor, rectifier, capacitor, display. It all ensure the functionality of this system, and the parallel connection of the piezoelectric sensor enhance the sensitivity and the enable accurate voltage reading, where the full bridge rectifier circuit rectify change from AC to DC and allowing the current to flow in one direction instead of two, and while it block the other opposite direction. And the LCD display provide a real-time voltage monitoring, and it improving the user interaction. The project also show the potential of piezoelectric technology in capture the energy from human activities and represent a step toward sustainability power generation. And it also encourage the exploration of alternative energy source, and it also serve innovative approach to generate electricity from footstep pressure. So I think that's all for me. Thank you so much from my panels, my supervisor, and that's all. And Assalamualaikum warahmatullahi wabarakatuh. Thank you. So this is the testing of my project. On the right is the piezoelectric sensor pad, where when I push or apply the pressure, it will generate electricity, and the yellow button is for me to show the cumulative of the voltage that have been generated. This is switch 2, where when I on the switch, the charge from the capacitor will release and charge the battery if the battery have a lower voltage than the capacitor. And the right side is the switch where it will operate the motor in this project.